call is now being recorded.
Right, let's get right into this session. So this session's about everything to do with graphs in GCSE maths. We have also got a graph summary sheet as well. So just on one page, it's got all the graphs that you need to know. So linear, quadratic, circles, cubic, your trigonometry graphs, and so on. So you can find that on our site if you do want that. So let's jump right into these questions. So we'll start off with linear graphs first. Remember, linear graphs are of the form y equals mx plus c, where m is the gradient, so how steep the line is. So if it was like that, that's positive. If it's going downwards, that's a negative gradient. So that's how steep the line is. C is the y-intercept, so where it's crossing the y-axis. So it says here on the grid, draw the graph x plus y equals 4 for the values between -1 to 5. Okay, so what we could do is we could do a table of values. There's a few different ways to do this, but I'll do a table of values so we can show this method, and we'll do different methods for other ones. So it wants it between -1 and 5. So when x is -1, what is y? Now what I'm going to do is I'm going to rearrange this equation x plus y equals 4 and make y the subject, because we're used to seeing y equals mx plus c. So to get y by itself, I'm going to minus x to the right-hand side. So I get minus x plus 4 for that. So minus x plus 4. So now that's in the form y equals mx plus c. Okay, so now let's substitute, well, we're going to substitute -1 in. We're going to substitute 0 in, 1, 2, 3, 4, and 5. Now you can just find 2 points, to be fair, and then using them 2 points, we can just join them together and you'll get the actual graph. But let's do it accurately. We'll do all values. So let's substitute in. We'll start off with x equals 0 first, because we'll do -1. So putting -1 into here, we've got -1, which is 1, and then 1 plus 4 is just 5. And then we've got x is 0, so -0, which is 0, plus 4, which is just 4. When x equals 1, -1 plus 4 is 3. When x is 2, -2 plus 4 is 2. And then we've got -3 plus 4, which is 1. -4 plus 4 is 0. And then -5 plus 4 is -1. So that's all the values we've got. Now each of them represent a coordinate. So for example, for this first one, it's -1, 5. For the second one, it's 0, 4. For the third, 1, 3, and so on. So it's x coordinate and the y coordinate, which I'm going to plot on this graph here. So we've got -1, 5, which is here. They might not even put the axes numbers on. You might have to do that yourself and come up with a suitable axes, but they've done it here. 0, 4, which is here. 1, 3, which is here. 2, 2, which is here. 3, 1, right there. 4, 0 over here, and 5, -1. So using a ruler, you would join them up because it's a straight line. Let's see if I can do that on here. Like so. So just like that, make sure it's a ruler, bang on straight line. Another thing I would say as well is always expect your graph to look like what it's going to look like. Now looking at this, with it being a negative gradient, I was expecting it to go down, and it's got a y-intercept of 4, so I'm expecting it to cross 4 on the y-axis, which it does. So that's a sensible solution that we've got. So let's move on. That's 3 marks. Okay, question 2. Find the equation of line L. I can see it's a straight line graph, so it's a y equals mx plus c graph, and I need to find out what m is, the gradient, and I need to find out what the y-intercept is, so what is c? Now c is easy to spot. I can see it's crossing the y-axis at 5, so I can just say c is 5. To find the gradient, there's a few different things you can do. You can draw a triangle on the graph and then do chain difference in your y divided by difference at x. But the method that I prefer is just choosing 2 points that lie on that line and just do the change in y. Some of you might have seen that as y2 minus y1 over change in x, which is x2 minus x1. And I'm expecting a negative gradient because it's going downwards. So if I get positive, I know I've gone wrong. So let's just choose 2 points on this line. I can see 2, 0 is a point. Not 2, 0, 2, 1 is a point on that line. And 1, 3 is also a point on that line as well. And all I'm going to do is change in y divided by change in x to find the gradient. So I can do 3 minus 1 over, so I did 3 minus 1. Go in the same order for x, 1 minus 2. 1 minus 2. 3 minus 1 is just 2. 1 minus 2 is minus 1. 2 divided by minus 1 is minus 2. So my gradient, my m value, is minus 2. So therefore, the equation of the line is just y equals minus 2x plus 5. And it works for any point you choose. I could have chosen any 2 points on that line. I still would have got a gradient of minus 2. Another thing people get confused with, they say, how do I know which way to minus? Like, how did I know it was 3 minus 1? You don't have to do 3 minus 1. I could do it the other way around. I'll still get the same answer, and I'll just prove it to you. If I did, for my gradient, I did 1 minus 3 this time, then what I also have to do for the bottom, I have to go the same way around. So I'm going to do 2 minus 1. Hopefully this does give us minus 2. 1 minus 3 is minus 2. And then 2 minus 1 is just 1. Minus 2 divided by 1 is just minus 2. So it's exactly the same answer. It doesn't matter which way you use. Okay, 3 marks for that one. Question 3, it says a line with equation x plus 2y equals 6 has been drawn on the grid. I can see it's a straight line graph. So again, it's a y equals mx plus c graph. They've just not rearranged it properly. Well, part A says rearrange the equation to make y the subject. So they're prompting you to do that. So let's make y the subject. Even if they didn't ask, I would recommend just making y the subject and get it in the form y equals mx plus c. So to make y the subject, I am first going to minus this x to that side. So I get minus x plus 6. Reason why I put x first is because it's y equals mx plus c. And then to get rid of that 2, I need to divide by 2. So I can say y equals minus x over 2. Rather than writing x over 2, it's better to say a half x. So it's better to keep your gradient out. Minus x over 2 is the same as minus 1 over 1x over 2, which is the same as minus a half x. That's how I got minus a half x. I'll just keep that there so you can use that as reference. So it's just good practice. Keep your number separate from your x so you can see clearly what the gradient is. Then plus 6. So we can see, not plus 6, sorry, 6 divided by 2 as well, which is 3. So we're dividing 2 both terms. So yeah, we can easily see our gradient is minus a half, and we can see our y-intercept is 3. What does the next question say? The next question says, write down the gradient of this line. Well, we can see the gradient quite clearly is the one in front of x, which is just minus a half. And that makes sense. It's a gradient going downwards as well. So it's all starting to link together as well. This graph also should be crossing 3 there, which seems sensible, which is less than 5, because it's got a y-intercept of 3. Write down the equation of the line. So equation of a line, so it's going to be y equals mx plus c, which is parallel. So what does parallel mean? Parallel means same gradient. So that's what that means, same gradient of the line with equation. So the equation that we've already just had, which we've already rearranged up here. So same equation, and passes through the point with coordinates this. Okay, so we're finding the equation of the line. So I need to find the gradient and y-intercept of that line. Now we know the gradient is going to be exactly the same as what we've just found because the line is parallel. So when lines are parallel, it means that they never meet. So they have the same gradient. So I can say the gradient is minus a half because there's a minus half here. And what's the y-intercept? Well, it says it passes through the points 0, 7. So 0, 7, if you look on the coordinates, 0, 7 passes the y-axis at 7. So that means the y-intercept is 7. So that only works if your x is 0. So I can just say my y-intercept, i.e. my c value, is 7. So our equation is just y equals minus a half x, so the gradient x plus 7. And that's our answer. So that's question 3. It's quite good that they prompted you to do all this, but sometimes they don't prompt you and you just have to figure it out by yourself. Okay, we've got loads of graphs on an axis. So you can see we've got P, we've got R. I'll just highlight them so you can see them quite easily. We have S and we have Q. Now, before looking at what the question's asking, they're all straight line graphs, so y equals mx plus c, where S and R have positive gradients because they're going up, so the m value should be positive. P is a negative gradient going downwards, so it'll be negative. And Q has no gradient, it's crossing the y-axis somewhere. So this equation, Q, will have the equation y equals whatever number it's crossing through. One other thing I can tell you as well, these are both parallel to each other, they have the same gradient, which is what we can assume. It looks like that, to be fair. But let's see what the question's asking. So it's really good habit to always analyze like graphs or what the question's asking before you actually look into the question, because you might even answer the question yourself. The diagram shows 4 straight lines, which we've established, labeled P, Q, R, S. The equations of the straight lines are these. So they've told us the equations for each of them as well. It says match each straight line with its equation and complete the table. So we already know, we can do Q. We know Q has no gradient. It's got a 0 gradient because it's just a horizontal line. And it's going to have the equation y equals a number since it's crossing the y-axis. And the one with only y equals a number is D. So therefore, D is line Q. So that one was relatively easy to do. So we've done D. I'll highlight them as we've done them. Okay. What else do we have? Well, the other one we can look at is P is the only one with a negative gradient, so where it's got a minus m value. So what I would do is make sure all these equations look like y equals mx. So this one does, that's got a positive gradient. This one here, I could rearrange this one and say it's y equals minus 2x plus 3. So I'll put the gradient first, and this has got a negative gradient. And only one of these lines have a negative gradient, and that is P. So B is P. So we've done that one as well. So it's that process of elimination. Now the other two is y equals 2x and y equals 2x plus 3. What does the plus 3 tell us? It tells us it's crossing the y-axis at 3. This one here has a c value of plus 0 because it's not got a c value. So it's crossing through 0. So both got the same gradient, 2x as expected. You can see S is crossing the origin, so at 0, and R is crossing just above, which is probably plus 3. So therefore, C will be R, and then A will be S. There you go, we've done all of them now. S, P, R, Q. Okay, perfect. Moving on. We're now on to quadratic graphs. So remember, quadratic graphs are U-shaped or N-shaped graphs. Giving you a bit of background about quadratic graphs of the form y equals ax squared plus bx plus c. Remember, quadratic graphs don't have to have these two values, but they have to have x squared in it minimum for it to be a quadratic graph. It can be U-shaped or it can be N-shaped, and it's U-shaped if a is positive. So if the coefficient in front of the x squared is positive, it's a U-shape, so it looks a bit like a smiley face. If it was negative, a, so like minus 2x squared, then it would be a negative face N-shaped graph. So that's how you can remember it. We've got a summary sheet with all that on as well, so you can get that from our website if you want to. So it says complete the table of values for y equals 7x minus x squared. So since I see a minus x squared here, you should be expecting an N-shaped graph when you're drawing this graph out. Let's complete the table of values anyway. So we've got x equals minus 1. So when x is minus 1, minus 1 squared is 1. It's probably worth writing this out actually, just to show you. So we've got 7 times minus 1 minus 1 squared. 7 times -1 is -7. And then we've got minus 1 squared. Minus 1 squared is 1, like we said. -7 minus 1 is -8. So try and not do it all in your head just in case you make a mistake. The next one's pretty straightforward. That becomes 0. 0 minus 0 is just 0. When it's 1, we've got 7 minus 1 squared, which is 1. 7 minus 1 is 6. 7 times 2 is 14. 14 minus 2 squared, so 17 minus 14 minus 4, sorry, is 10. 7 times 3, 21. 21 minus 3 squared, which is 9. That gives us 12. Again, we get 12 for this one, so just substitute in and we get 10. So that's the values we get. We're just substituting the x value into the equation. And now we are plotting it. So we completed the tables. On the grid, we're going to draw the graph now. So we're just plotting these values. We've got -1, -8. How do we know where -8 is? Well, you know there's 10 boxes. We need to figure out the value of one box. There's 10 boxes between 5 and 0. So what we can do is 5 minus 0 divided by 10, which is 5 divided by 10. And 5 divided by 10 is a half. So each box is 0.5. That's how you work out how much each box is, which makes sense. So 0.5, 1, 2, 3, 1, 2. Oops, I did the last one wrong. 1, 2, 3, 4, and then 5. So that makes sense. Just double check that. So we want -1, -1, -8. So if that's -5, this is drawn a bit horribly. -1, -6, -7. So -8 is here. So that's -8. Hopefully it's not too terrible like that. Okay, what's the next one? The next one is 0, 0. Easy enough, that's just there. We've got 1, 6. So 1, 6 is here. 2, 10, which is right there. 3, 12. So here's 3. That's 11, 12. We've then got 4, 12, which is here. So 11, 12. And 5, 10. So right here. Now, a mistake that everyone tends to make is they join this up like it's dot to dot. So like not a smooth curve. They just do it like that. You will not get the marks. You have to draw it as a smooth curve. So like so. We'll try again. It's a bit tricky doing it on a tablet compared to a paper. But yeah, it has to just be a smooth curve. Going down like so. Okay, perfect. So yeah, they only give you the marks if it's a smooth curve drawn and not dot to dot. Okay. It then says use the graph to find an estimate of the turning point of the graph. Now, the turning point is basically where the graph turns. So you can see with a U-shaped graph, it turns here, and with an N-shaped graph, like what we've got, it turns just on the top here. So when it's actually turning, and we can see the turning point is right here. So between, I'm going to do it in a red line. You can see the turning point is right there. In between 3 and 4. Since 3 and 4, we've got 3, 12, 4, 12. In between 3 and 4, for the x, that's 3.5. So our x value we can see here is 3.5. So I can put that here. And we just need our y value, so we can just read it off. They just want an estimate. And it is roughly around here, I would say. So that's 10, 11, 12. You could say that it's like 12.2-ish. So I could just write 12.2. But you'll get a range of answers for y that they'll accept. So just looking at the mark scheme, they accept a number for y between 12 and 13, but for x you have to have 3.5 because 3.5 is bang on in between the 3 and 4, where it's exactly the same for these two. So yeah, you get a range of answers you can choose for the y value for that, since it's just an estimate. Okay. It then says find the solutions to equation 7x minus x squared equals 0. So to find the solutions, it basically means where it crosses the x-axis. Now we can see very clearly there's one point we can see here, which is 0, which is where it crosses the x-axis. But we can't see the other one. This graph will eventually go down like this, but we can't see what this is, but we're expecting the number to be higher than 5. And anyways, so how do we do that? We just need to solve this. We can factorize that. So we can say, we can pull an x out, just like so, and start factorizing. X times something gives me 7x, that's 7. Then minus x, because x times minus x is minus x squared, that equals 0. So what this is saying is you've got two numbers, so the x and 7 minus x, them two numbers are timesing to equal 0, and one of them numbers have to be 0. So 0 times something gives you 0. So therefore, either x could be 0, which is expected because we can see x is crossing 0 on the x-axis, or we can have 7 minus x equals 0. So solving this, I just need to make x positive. I'm going to bring x over to the right-hand side. So x equals 7. So instead of writing it like that, I'll just write x equals 7. So there are two values. X could equal 0 or x could equal 7. 7 seems like a sensible answer since this graph is going to continue downwards, and it does look like it will cross 7 when it gets over there. So that's a sensible answer for that one. So x equals 0 or x equals 7. They're your solutions. Okay, moving on to the next quadratic equation question. Here is the graph of y equals x squared plus 2x minus 5, which seems reasonable. It's a positive x squared coefficient, so therefore it's a U-shaped. So yeah, that's good. It says here, write down the turning point of the graph. Well, where is the turning point? The turning point is where it turns, which you could say is roughly there. So middle right here. So we can use symmetry to kind of figure that out. So if we look at this point here and this point here, which is 0 and minus 2, the number between 0 and minus 2 is minus 1. So then you use symmetry to figure out a turning point is at minus 1 for this point here. Now we just need to read off where it is on the y-axis, and that's minus 6. So minus 1, minus 6, that's our turning point. Part B says use the graph to find the roots of the equation x squared plus 2x minus 5, which is the equation of the graph, equals 2. Usually we find it when x equals 0. So if this question said equals 0, we usually just read off them two values here. But this time it's saying x, well, it equals 2. So we need to draw the equation of the line y equals 2. So that's where y has become 2, right? So here's your y. You've changed y to 2. So the equation of y equals 2, you should just know that's a horizontal line through 2 right there. Let me draw it as a straight line. 2 seconds. Of course, use a ruler for this. Okay, yep. So there's y equals 2. And we're finding the roots of that, so where it crosses, basically. And that is right here and right here. So we can say approximately here, and we're reading off approximately there. Let's figure out the value of one box. So between 0 and 2, we've got 10 boxes. So that would be 1. It'd be 1 in between. That would be minus 3. Just like that's minus 1, minus 2, minus 3, minus 4, so minus 5. 1, 2, 3, 4, 5. We've got 5 boxes in between 0 and 1, so each box would just be 1 divided by 5, which is 0.2. So that's how you work out the value of one box. Okay, so this one here, we've got 1.2, 1.3, 1.4, no, 1.2, 1.4, 1.6, 1.8 for this one here, that's 1.8. So we can write that down. And the next one, so this one over here, we can say that's roughly minus 3.2, minus 3.4, minus 3.6, minus 3.8 for this one here. So minus 3.8 and 1.8. So they're your two answers to the roots. So that's that quadratic equation. Another one. So let's move over to cubic. Now, cubic is something that's got x cubed in. So let's have a look. So it says complete the table of values for y equals x cubed minus 3x plus 2. So we're expecting the graph to either look somewhat like one of these, essentially. Since x cubed is positive, it's going to look like this first one. If x cubed was negative, it would look like this one. Again, we've got that on our summary sheet as well if you do want to get that. So that's what a cubic graph looks like. Let's plug in the values. We've got minus 3 cubed, which is minus 27. Minus 27, and then minus 3 times, it's probably better to put it in actually. So minus 3 cubed minus 3 times minus 3 plus 2. So putting that all in the calculator, you get minus 16. So I would recommend just doing it to the side, not doing it in your head if it's got like a minus number, so you don't get confused with signs. Same for these, so you get 0, you get 4 for this one. For 0, well, that's just 0 minus 0 plus 2, so that's just 2. For 1, it is 1 cubed minus 3 times 1, which is minus 3 plus 2, that gives you 0. We've got 2, 4, and 3, 20. So each of them are coordinates, just like all the last examples we've done, and we're just plotting them on. So minus 3 minus 16, right there. We've got minus 2, 0, which is right here. We have minus 1, 4, right here. We've got 0, 2, which, because this is 0 and 4, then halfway would be 2, so that's just there. We've got 1, 0, which is right here. 2, 4 goes back up again. And then we've got 3, 20 right on the top. Now, just like the last questions, we are not joining them together like dot to dot. We have to draw a smooth curve, otherwise you lose marks. And as expected, we said it's going to look somewhat like that, and it does. So let's join them together using a smooth curve. And there you go. You get something that looks like this. As expected, a cubic graph. Let's move over to a different graph. We've now got reciprocal graphs. Now remember, reciprocal graphs are of the form y equals 1 over x, or anything over x. So in the question, we've got 6 over x. Now the way they look are like this. So 1 over x would look something like this. Now the reason why it never touches the axes is because we cannot divide by 0. You can't divide by 0. So if you put divide by 0 in your calculator, so I can show you, you get a maths error, somewhat like that. So you can't divide by 0, which is why it never touches the axes. One other thing I want to mention as well, if this had a minus in front of it, what happens is they come here instead. So if there's a minus in front of it, they just flip to the other sides. Okay, so you should have a rough idea what y equals 6, the x now looks like. So since we've only got the positive axes here, you can see they've not given us the other negative axes here. So I am expecting something like this. So this part here of the graph. So let's see what we get. Let's substitute the values in. So we've got 6, complete the values. So substituting x equals 0.5 into here, we've got 6 divided by 0.5, that is 12. 6 divided by 1 is 6. 6 divided by 1.5, we get 4. 6 divided by 2 is 3. 6 divided by 3 is 2. Divided by 4 is 1.5, 1.2, and 1. Okay, let's sketch all these points on. So we've got 0.5, 0.5, which is here in between 0 and 1, and 12 right on the top, right there. 1, 6, 1, 6, 1.54. We've got 2, 3, 3, 2, 4, 1.5. So there's 1. Let's figure out, don't just guess it, actually figure out where it is. So 1, we need to figure out the value of 1 box. So between 2 boxes, between 2, sorry, we've got 0 and 2, we've got 10 boxes. So if we do 2 divided by 10, that's 0.2. So each box is worth 0.2, which makes sense. 0.2, 0.4, 0.6, 0.8, and 1. Okay, so that makes sense. So we're plotting, what are we plotting? 4, 1.5. So 4, here's 1, that's 1.2, 1.4, that's 1.6, it's in between here. So let's rub that out. 1.245, so roughly here. I've seen a lot of kids just draw it on and just guess where it is, but the examiner doesn't want that. They want you to actually plot it as accurate as possible. We've got 5, 1.2, so 5, 1.2 is here, and we've got 6, 1, which is here. So it looks exactly like the graph that we've sent above, and just like last time, do not do dot to dot with each of them. Draw a smooth curve, passing through all the points. And there you go. A reciprocal graph as expected. So if you were like had the negative side, it'd be on the negative bottom quadrant, just like here, if we did have the other side of the graph as well. Okay, moving on. We've got 9 graphs. So we can see like this is a reciprocal graph, so 1 over x or any number over x. We can see this is a quadratic n-shape, so minus x squared. We've got y equals mx plus c, negative gradient, y equals mx plus c, positive gradient, and so on. So you should have a rough idea what every sketch and with the equation with it. So I can see this is potentially a cubic graph because it's got the hump. So it says write down the letter of the graph that could have these equations. So starting off, let's start off with the reciprocal since we've just worked with the reciprocal. Y equals 3 over x. I'm expecting it to look like a reciprocal graph, and we've got 2 reciprocal graphs here. We've got this one and we've got this one. Now, because there's a positive sign in front of it, there's no negative sign, it's just going to be like this one here. If it was minus 3 over x, it would flip over to the other side. So the last one is A. Let's look at the other ones. Y equals 3x minus 2. Well, the gradient is positive, it's going upwards. And we've only got one graph that has a positive gradient, that's H here. The other 2 y equals mx plus c graphs are negative gradients, so it can't be them ones. So the first one is H. And then finally, we've got a quadratic U-shaped graph because that coefficient of 2 is it's positive. So it's a U-shaped graph. So where's our U-shaped graph? We've got D, or we've also got I as well. So they are U-shaped graph. B is N-shaped, so that's negative x squared. It's not that one. So which one is it out of these? Well, we can see that the end number is minus 3 on here, which means that it crosses the y-axis at minus 3, because if you substitute x equals 0 in, you get 0 minus 0 minus 3. So when x equals 0, y equals 3. So we need it to cross the y-axis at 3. So out of D and I, we can see it crosses minus 3 here. Here it crosses above 0, so it can't be that one. So therefore, it's D. There you go. That's that one. So you do have to be really familiar with what all your graphs look like and some theory behind all of them. Let's move over to exponential graphs. So on the grid, sketch the curve with equation y equals 2 to the power of x. Now, all exponential graphs are of the form y equals, I'll just say k to the x. K could be anything. And they always look like they're tending to infinity. They just continue forever upwards and grow exponentially. So that's what the graph I'm expecting to look like. It says on the grid sketch. So sketch just means not draw it accurately. So all the other questions we were plotting the points here, we are not being accurate. It's just a sketch. It says give the coordinates of any points of intersection. So we know the graph looks like this. And it's saying give the coordinates of any points of intersection, which is right here. So when x equals 0 is where it crosses the x-axis. If I substitute x equals 0 into here, so when x equals 0, y equals 2 to the power of 0, and anything to the power of 0 is 1. So therefore, this here is 1. So that's the fact that you need to know about the exponential graphs. Okay, moving on. We've got another one where they've given graphs. It says here are 4 graphs in the table below. Match each equation with the letter of its graph. So we can start off with the exponential one. We can see C is an exponential. And the only exponential one here is y equals 2 to the x. So I can say that is C. There's no other ones. So that one would be C. Looking at the other ones, we've got a cubic graph. Now, the cubic graph, it could potentially be B, but it could also be A, but there's other options as well. There's sine and cos. So let's work with sine and cos first. Your sine graph always starts at 0, and your cos graph starts at 1. So this is not a cos graph sine graph, because sine graphs go like this. So therefore, part A is sine, and D is cos, so I can put that there. So then that just leaves B being the cubic. So if you ever have like, you're a bit confused, there might be 2 that might be a cubic. So A could potentially have been a cubic, but it's 2 even, or this could have been a cubic. Do your other letters first and then eliminate it, is what I would say. Okay. Let's have a look if you've got any more here. So that's really the end of it. I should have really included an equation of a circle, to be fair, but I've not got equation of a circle. So we'll probably do that in another session, equation of a circle, but that's majority of the graphs covered for that one. So I hope that was helpful. If you do want the graph summary sheet where it's got all the graphs on there, so your trigonometry ones, your circle ones, and so on, you can get that from our site as well. And if you want to have a glimpse on it as well, do drop us a message and we can show you a glimpse of it before you get it. But I hope that was helpful, and we'll see you on a future session. Thank you for joining.